we want to write an equivalent series with the index of summation beginning at n equals 1. So the first sum we have from n equals 0 to infinity, x to the n over n factorial. So we want to rewrite this starting at n equals 1 and then going to infinity. So what we have to do here is increase this n by 1, and then that will make us decrease these n's by 1. Okay. So if you increase this, you have to decrease the other ones. And so if we decrease n by 1, that'll be n minus 1. And so this is our sum. And this works because n, here the coefficient of n is 1. But what happens if the coefficient is not 1? So let's look at another example. So we have the sum, n equals 0 to infinity. We have x to the 2n plus 1 over 2n plus 1 factorial. So here we want to increase, we want to start at n equals 1, go to infinity. So what that will require us to do is increase this n up by 1. But if we increase n by 1, well, we would have to decrease these two n's. And so if we decrease the n's by 1, we're actually decreasing the whole thing by 2, because that's the coefficient in front of the n. Okay, so that would just be 2n, and then we would subtract 2 to the whole thing, which will be 2n minus 1 over 2n minus 1 factorial. So this is a nice little shortcut to solving this problem. If you want to do it the long way, all you would have to do is substitute n minus 1 in for n. So you would have x to the 2 times n minus 1 plus 1 over 2 times n minus 1 plus 1 factorial. You would distribute the 2. You get x to the 2n minus 2 plus 1, and then 2n minus 2 plus 1 factorial. Minus 2 plus 1, that's minus 1. And then you just have 2n minus 1 as the exponent, and we're going to put that over 2n minus 1 factorial. So you do end up getting the same answer.